this is going to be completing the square. Now, this section is not probably the most fun section, but it is useful when you do, it makes problems a little simpler. So let's do a couple problems so that we can kind of get the deal of what completing the square does. So really what we want with completing the square, we want a perfect square. And if you think of a perfect square in terms of a number, we think of the number 4, the number 9, the number 25, the number 16, the number 36, 49. All of these numbers are perfect squares because you can have 2 times 2, the same number, equal a number. 3 times 3 gives me 9. 4 times 4 gives me 16. So these are the same numbers. So when we talk about perfect squares with binomials, or something that looks like this, y squared minus 14y plus 49, well, this is actually a perfect square because if you think about it, 2 numbers that multiply to get 49 and add up to get negative 14 will be negative 7 and negative 7. Notice that these two are the same thing, so this can be rewritten as y minus 7 whole quantity squared. Okay, so similarly, you can also have x squared plus 2x plus 1. Well, 2 numbers that multiply to get 1 and add up to get 2 would be x plus 1, x plus 1. Notice that they're the same thing, so I can write it as x plus 1 squared. So what we really want to do is make it as a perfect square if it's not already. So, for example, how can I make x squared minus 26x a perfect square? Because this is clearly not a perfect square. We can't factor this. Well, one of the things that we can do is we can just take this value of b, and let me just go ahead and put it in a different color. So what we're going to do is you want it in this form, x squared plus bx. Okay, something that looks like that, which this is it. What we're going to do with this b, and I'll put it here, you first want to identify b. Okay, so which one's my b? Then what you're going to do with that b, you're going to take b and divide by 2 and square it. Okay, so I'm going to take this b term, okay, I'm going to divide by 2 and then I'm going to square it. Okay, then what you're going to do is add and subtract. Whoops, this looks really ugly. Add, subtract that term, and then finally just factor. Okay, so let's take x squared minus 26x as an example. Okay, so we're gonna take that. Now the first thing that we want to do is identify our b. B in this case is going to be this negative 26. This negative 26, we're going to divide it, and then we're going to square it. Okay, so negative 26 divided by 2 is going to give me negative 13. And negative 13 squared is going to give me 169. So what I'm going to do with this 169 is that I'm going to add and subtract that term. So I'm going to add 169, and then I'm going to subtract 169. Because in the end, this 169 was not there. But notice that now I can just group this thing, and this is actually a perfect square because this is just x minus 13 squared minus 169. Because here, x minus 13 times x minus 13 is going to give me all of this. Okay, so that's basically the basis of it. So I combine this to make it a perfect square. You have a lingering term here, but you'll see that that's remedied in a little bit. So how is this going to help us with the equations? Okay, so solving using completing the square. Solving by completing the square. Okay, so how is this going to help us? So let's say you have something that looks like this. X squared plus 6x minus 1 is equal to 0. Okay, so how do you complete the square here? So same thing. The first thing that you want to do is isolate all x's on one side and numbers on the other. Okay, so we're going to separate everything out. Okay, whoops, not a 3, 2. Next, what you're going to do, identify b and find b over 2 squared. Okay, add b over 2 squared on one side, on both sides of the equation. Okay, now you can always add and subtract like how we did before here. You can add and subtract, but the thing is, like, when we have an equal sign, you're just going to add it over. So notice how if I add the 169, you're going to have it on the other side. So that's why it's better to just add on the other side of the equation. Okay, and then factor the perfect square and solve. Okay, so that's what you really want to do. So keep these little guidelines, and then we'll do these. It'll really help. Okay, so let's do an example. So we had our example of x squared plus 6x minus 1 equals 0, and we want to solve this thing. Okay, so the first thing that you want to do is isolate all the x's on one side and the numbers on the other side. So right now I have this x squared and the 6x on one side. I'm going to move this one over. Okay, so I'm going to have x squared plus 6x equals negative 1. Okay, so I have all my x's on one side and then all the numbers on the other side. Okay, now the next thing that I'm going to do is identify this b term. My b term in this case is going to be the 6. So I'm going to take 6 divided by 2, and then I'm going to square it. So 6 divided by 2 is going to give me 3. I'm going to square it. I'm going to get 9. Okay, so what I'm going to do is I'm going to have x squared plus 6x equals negative 1. And what I'm going to do is I'm going to add this 9 to both sides of the equation, because that's what it says. I'm going to add whatever I got to both sides of the equation. Okay, so now what's going to happen? Well, now this is a perfect square. Two numbers are multiplied to get 9 and add up to get 6. That's just x plus 3 whole quantity squared. This equals to negative 1 plus 9, which gives me 8. Oh, and now we can finally solve it because we've just learned how to solve something like this. I'm going to take the square root to both sides. Square root, plus or minus. So we're going to have, this is going to go away. X plus 3 equals plus or minus 2 square root of 2. Subtract by the 3. And what I'm going to get is x is equal to negative 3 plus or minus 2 square root of 2. Okay, and that's my answer. So notice, we had to do an extra step by completing the square, and then in the end, we got our solution. Okay? So let's do another problem. I'll do it right next to it. Okay, so let's say you had something that looked like this. X squared plus 10x plus 4 equals 15. Okay? You can try it out first, or you can do it with me. So first, let's put all the x's on one side and let's put all the numbers on the other side. So all the x's are here. I'm going to move this 4 because this 4 has nothing to do over here. So I'm going to have x squared plus 10x equals 11. Okay. I'm going to identify my b term, which in this case is 10. Take 10 divided by 2 and square it. This is going to give me 5 squared, which gives me 25. Okay. So now this 25, what I'm going to do is I'm going to add this 25 to both sides of the equation. Plus 25 plus 25. And now I can factor this because this is now a perfect square. This is going to be x plus 5 whole quantity squared is equal to 11 plus 25 is going to give me 36. Okay. Finally, I'm going to take the square root to both sides. Add a plus or minus. This will go away. I'm left with x plus 5 is equal to plus or minus square root of 36 gives me 6. And then I'm going to subtract this 5. So I get x is equal to negative 5 plus or minus 6. This is just negative 5 plus 6. negative 5 minus 6. This gives me a positive 1, and this one gives me a negative 11. Okay, so these are my solutions. Okay, so it's not too terrible bad. Now, it does get a little bit bad when this number is not divided by, or divisible by 2. So let's say you had this dreadful problem. X squared plus 3x minus 5. Oops, sorry, this should be a minus. Minus 3x. Minus 3x minus 5 equals 0. So let's say you had something that looked like that. Okay? Well, first of all, let's just identify our b and also move the 5 over because this has nothing to do there. So x squared plus 3x equals 5. Okay? So what we want to do, identify our b. Our b in this case is this 3. So 3 divided by 2, and then we're going to square it. So this is going to give me 9 over 4. Do not put it as a decimal. Just leave it as is. Okay, so this is 9 over 4. So what we're going to do now is that we're going to have x squared plus 3x equals 5. And what we're going to do, we're going to add this 9 over 4 here. We're going to add this 9 over 4 here. Okay? Now, here we get to a problem because now we have to factor this. Okay? Now, this should be an x, but what is this going to be? Oops, this shouldn't. I messed up already. This should be a minus. This should be a minus. Right? And this should be a minus. Okay. All right, so now we still run into the issue because you have this 9 over 4 and then you have this minus 3x, okay, that you need to kind of figure out. So this is kind of hard because it doesn't look like it's a perfect square, but it actually is. Okay, if you think about it, what times what gave me 9 over 4? Well, that was just this negative 3 halves. So this is actually negative 3 halves. Okay, and if you look at the rest of the problems that we've done, everything that was in the parentheses after we divided by 2, right, ended up being our factored form. See here how this was a 5? The 5 was our factored form. So, see this negative 3 halves, this negative 3 halves is going to go here. Okay? Now, all we got to do is just add this 5 plus 9 over 4. And that's just going to give me 29 over 4. Okay. Now what we're going to do is we're going to take the square root to both sides. So square root this side, square root this side, plus or minus. That's going to get rid of that. So x minus 3 halves is going to be equal to plus or minus square root of 29 divided by 2 because the square root of 4 is equal to 2. Now all we got to do is just add this 3 halves to the other side. So we're going to get x equals 3 halves plus or minus the square root of 29 over 2. Okay, that is my final answer. Okay, so I'm going to do another problem in the next video. That way, something that looks like this. And then I also will do a problem when there's actually a coefficient right in front of the x squared.